Hi. I'm Kevin from NCD Group. Today we're going to take a look at how the first tab works. This is the default tab that loads when you open the app after choosing the language you want to access the API with. This first tab is a solar system simulator, where you need to fill in the date and time fields in order to get the position of the celestial body you're looking for. We'll start by entering the date, either automatically or manually, and selecting the planet or celestial object whose heliocentric angle we want to calculate for that specific date and time. As it says at the top, in this tab we calculate the distance in astronomical units, as well as the absolute and relative angles, relative to Earth, between the Sun and the object you choose from the lower combo box, where you can find everything from Mercury to Pluto, including the 3 main asteroids in the asteroid belt. The error margin or angular resolution for position is up to 12 hours. We're going to get 2 types of diagrams. One for inner planets like the first image you see here, where we can spot Mercury, Venus, Mars and the asteroids. In this diagram, 180 pixels in length represent 1 0 and a second diagram for the outer planets. In both diagrams, at the bottom left of the screen, you will see some data. The Julian date, the distance from the Sun of the selected object, the angle relative to the x-axis equals 0 which lines up with Earth's perihelion on January 3rd, the Earth's angular position in relation to its perihelion and the current distance between the 2 objects. You'll also notice some concentric circles, which represent the average orbits, mean radii, of each object, each shown in a different color. You can see in real time how far each object is from its average orbit. Also, whenever you move the pointer around the canvas, you will see in real time the distance and angle from the Sun to the spot you're pointing at. From minute 2 of the tutorial onwards, you'll also see how the outer objects are represented. Here's a trick to compare the orbital speeds of different bodies. If you go to the spinner labeled "Increase number of days" to simulate orbital motion, and you type in a number like in the example every time you press enter, the planet's new positions are drawn on top of the previous ones, keeping the last dots visible. This way, you can quickly see how they move over time. You'll notice, for example, the small arc traced by Pluto and Neptune, compared to the many revolutions made by the inner planets, or the half-turn Jupiter has completed. You can also get a nice visual of how eccentric Pluto's orbit is in this particular date. It's actually closer to Neptune's orbit than to its own average one. And just a reminder, all this data was made possible thanks to NASA's New Horizons mission. Thanks for your time and happy space exploring.
If you like our content, hit like and subscribe to the channel.